Good morning, everyone. A key added value of the ALDREN approach is to propose a predicted energy rating, often known as an asset rating, which will be verified by measurements. ALDREN will do this by adopting a philosophy of design for measurability. We have to create a position where everyone can see that what is being measured is the same thing that was being predicted at quite a granular level, so monthly totals for different submeters. There then should be no reason for the predicted and measured values to differ significantly. If they do, diagnosis should identify what is going wrong. This is the philosophy of the ALDREN performance verification protocol. So how will we do this? We are all aware of the energy performance gap, but how exactly is it defined, especially in the case of deep renovation? So here we see the calculated energy use before a renovation in the existing building, then after the renovation when improvements have been made. We can also measure the amount of energy the renovated building is using. And we can compare the predicted energy use with the measured energy use. But is that the energy performance gap? We are saying no. The protocol must be much more precise. Let's look first at the evidence for the energy performance gap, as shown in the previous slide. Unfortunately, at the moment, we do not design for measurability. Metering is not put in place to measure outcomes that can be compared with design predictions. The best we can do is compare metered whole building energy intensity with an energy performance certificate grade. And this graphic shows data for large office buildings in London. It shows on the y-axis the total for all energy used in the building, which is what is being measured by utility meters, and it's normalized to kilowatt hours per square meter. The data is arranged so that each building is placed into a different cohort according to its EPC grade. And then the data points are arranged in ascending order. The green horizontal lines show the median energy intensity for each cohort. The data does show a limited correlation. The median values do get better, that is lower, as the EPC grade improves. But there is so much variability that this marginal trend is of limited statistical significance. ALDREN aims to provide an EPC rating which the market could trust to be giving a better indication of the operational energy efficiency of a building, because the predicted rating will be verified by measurements. So how will we do this? The first step is to use a like-for-like comparison. We need to be sure that we have the same boundary conditions for the predictions as we have for the measured actual building. And we must make sure that we compare the results for the same energy uses. But we also have to try harder. We need to use a better model. And we need to ensure that the real building operates correctly. And we can use a better model as a guide for correct operation. So I want to look at these 4 points in a bit more detail. So if we look at ensuring that we are applying the same boundary conditions. This diagram at the moment shows where we started, trying wrongly to compare energy use under standard conditions with energy use under actual conditions. What we need to do is rerun our model under actual conditions so we can then compare predicted and measured energy use under the same boundary conditions. The next step is to look at comparing the energy use of different energy end uses and making sure that the predicted energy is being compared with the measured energy for the same things. For offices, we are most interested in the so-called base building. And the base building energy uses are the ones that can be controlled and influenced by the landlord of the office building, unlike the energy use of the lighting and equipment installed and used by the building's tenants. However, in ALDREN, we will probably be focusing on a subset of these, and these are likely to be the heating, fans, cooling, and hot water, because these are the subjects of the EVCS. The ALDREN approach requires meters to be installed so that the energy use predicted for each of these energy end uses can be measured by meters. Now I want to move on to the try harder steps. The third element of the ALDREN approach to verification is to use a better model. This we plan to do first by calibrating the model, using energy data measured for the building before it is renovated. So we need to rerun the model for the existing building under actual conditions, measure the building under actual conditions, and then calibrate the model so that it is predicting the energy use that is being measured. This has the big advantage that the improvement measures can be decided based on this calibrated model, and therefore will be a lot more reliable in giving the owner of the building a good idea of the actual energy savings that should be achieved and the cost effectiveness of the deep renovation level proposed. The fourth element of the ALDREN approach is also about using a better model. The detail of simulation model proposed for ALDREN differs from current EU practices, but is not groundbreaking in the sense that it has become routine practice in Australia for large commercial offices and is used in the United States and Canada under the guidance of ASHRAE 90.1. The key difference is that we propose the dynamic simulation should be of both the building and its HVAC system and controls, with a time step of 1 hour or less. And we recommend the simulation should be undertaken to predict heating and cooling demands under a range of expected conditions of use, to check the resilience of the base building energy use to plausible future scenarios for tenant hours and intensity of use and weather. It is to be expected that different tenants may have longer or shorter hours of use than the standard. Some spaces may end up being unoccupied for significant periods. We need to check if the HVAC is designed so that different zones can be serviced independently and only occupied zones are serviced. This will help measured energy match the predicted energy use. This graphic illustrates how an advanced simulation model can drive both the design of a building or deep renovation and then be used to help fine-tune the building during its early operation so that it operates in line with the design intent demonstrated in the model. We are aware that in much of the EU, building services engineering teams currently lack the skills to do robust detailed simulation of HVAC systems and their controls, as it is done routinely in Australia and North America. The ALDREN Performance Verification Protocol will therefore offer an alternative approach, which is being promoted by another Horizon 2020 project called Quantum. The Quantum Performance Test Bench tool aims to get written into tender documents and so into the contract every significant data point for plant operation and control. The contractor is then required to define what should happen for this data point when the building is operating. And once the building is in early operation, an independent verifier is asked to compare what is happening for that data point with what the contractor said should be. This produces a robust defects list for the contractor to resolve so that the building does indeed operate as intended. To conclude, I want to put the ALDREN approach into context. We are aiming to create the EVCS so that it goes well beyond the conventional asset rating by virtue of it including verification by measurements. The verification tool will also collect relevant contextual data which describe the actual conditions in a building during the assessment period, such as occupied hours and a schedule of activities by functional space in and around the building. We will not produce an operational rating because development of a harmonized European procedure to calculate an operational rating falls outside the scope of the ALDREN project. But collection of the contextual data will enable those adopting the ALDREN procedure to produce an operational rating using other schemes. The philosophy of ALDREN can be summed up by this logo: design for performance. Thank you for your attention.